So we can't take the square root of a negative number. We know that. And in this case, for g of x, I mean, just go back up here, look at this. G of x, we also can't have x be equal to 0. So for g of x, that domain limitation is, I mean, x has to be greater than 0, right? So what we're replacing x with is this x squared minus 16. So um, we're really what we're doing is we're solving this inequality. Where is x squared minus 16 greater than 0? Well, we could try to do some factoring, but really we could do some we just extract the square root. So what I'm going to do is add 16 to both sides of that inequality. Remember, treating inequality like an equation until you divide by a -1. So I'm going to get that as plus 16, and I'm going to take the square root of both sides of this. So x has to be, I'm getting two answers, right? X can be -4, x can be +4. So then we get to decide when is this thing going to be greater than 16? Well, we know x can't be, let's see, in between. I think the domain. Let me just tell you where I think the domain's going this, and I'll suss out why or explain why I think it's that. Come on, can I move this stuff up? I guess not. So I think the domain's going to be x has to be greater than 4, because when it's equal to 4, it's 0, right? So I'm gonna say I'll write this in an interval notation. Can't be equal to 4, and of course we can't get to infinity. I think that's the domain. Now, why can I ignore the -4, or why can I ignore anything between -4 and 4? Well, wait a minute here. If I want to think about the graph, let's just concentrate on that graph of x squared minus 16. I know that's a parabola that's been shifted down 16 units, right? I'll pretend that's 16, and I know it looks something like this. And I know it crosses the x-axis at 4, 0, and at -4, 0, because we found that with the inequality. And see, the thing we've got going on here is we've got x squared minus 16. So anytime I have a number less than 4, y is going to be negative. I can't take the square root of that negative number, right? And yes, it doesn't, uh, uh, now that I'm thinking about this, maybe when x is less than -4, I'm also going to get an answer because that turns positive. So I'm gonna adjust my domain notation. I think the domain is going to be -infinity until -4, open for both. I'll skip over from -4 to 4, and then to infinity. I don't know what my upper math says. I suspect that's going to be the answer. Just a minute. So when I graph the composite function on Desmos, and that does agree with me that it agrees with my second decision that the domain is going to be -infinity until -4 and 4 to infinity. Okay, so that's what happens, and when you're doing that kint, you got to make sure you're following order of operations, of course, when you're doing that. Okay. Now the second part of this question asks to nest it the other way, and this is tricky stuff because what you think about is well, if I'm going to square this, doesn't that become 1 over x and then minus 16? So that would just say, well, x can't be equal to 0. But the trouble is those original domain limitations never disappear, even if you can algebraically remove them. They're always there. They're always with us. So in this case, x has to be, so that original domain, that original function 1 over the square root of x has to be greater than 0. That can't go away. So it's not just x can't be equal to 0, x has to be greater than 0. Now let's go back and take a look at the graph and see if that's true. So you see when I graph the two different functions, oh, why did I only write 1? It should be minus 16. So that just shifts it down. That just shifts it down more, right? So even though I'm not going to go back and redo that, but that black graph should be shifted down on the graph. But you see how the 1 minus 16 doesn't include that domain. See the black graph. That domain is -infinity until 0 skip over 0, 0 to infinity. But the purple graph is the one that's got the two nested. I didn't do anything algebraically. All I did is I had Desmos take and insert that function into that. So the original domains here, the original domains never disappear. They're always with us. So that's why this purple graph doesn't include that. So when you're finding composite functions, make sure you think about the original domain and when you limit it. I'm going to ask you this on an exam, and maybe the next quiz even will have something like this. Okay, so hopefully that helps.